Hi everybody, it's Mrs. Dunn. What we're going to be doing in this screencast is solving exponential and logarithmic equations. It's very simple, there's one outcome, but there's a lot of examples. So I'm going to try to go through as many examples as I can so that you are successful when you go to do these kinds of problems in your homework, on the tests, and on the final. So the first property we're going to talk about to help us solve these equations is the base exponent property. And basically what I want you to catch from this is that when you have the same bases and these expressions are equal to each other, the exponents have to be equal to each other. It's specifically this property that's going to help us solve this problem. So 2 to the x minus 3 and 16 to the 5 minus x. And we're asked to solve for x. Well, we can make the bases of these expressions the same. See, because this is 2 and 16 is a power of 2. It's 2 to the 4th. So I'm going to rewrite the expression so that they both have a base of 2. So I've written the left side the same, 2 to the x minus 3, and the right side is 2 to the 4th, which is being raised to the 5 minus x power. 16 is 2 to the 4th. Then when I multiply out that 4, so I'm distributing the 4 on the right side, I get 2 to the x minus 3 is equal to 2 to the 20th minus 4x. Now the bases are the same, and so I can set those exponents equal to each other and solve this equation, which I know you know how to do. We'll add 4x to both sides, we'll add 3 to both sides, and then divide by 5. So x is equal to 23/5. Okay, let's look at the next one. Here's an example where we cannot make the bases the same. There's no power of 4 that's equal to 25. But we can solve this equation by recognizing this is an exponential equation. Let's write it in log form. So it would be log base 4 of 25 is equal to x. That's simply converting between exponential form and log form. And then we can solve this using the change of base property. Or you could even just plug it in your calculator if you have the change of base programmed in. So the log of 25 divided by the log of 4, or the log base 4 of 25, is what x is going to be equal to. I think I forgot to write down the answer, but the answer is 2.322 approximately. So this is the exact answer, and this is our approximated answer. So the exact answer and the approximate answer look like this. So make sure you're paying attention to that when you're doing your homework. A lot of times students make the mistake and think, oh, the decimal is the exact answer. It is not. The decimal is the approximate. Okay, one more property that we want to talk about here, and this property is the property of logarithmic equality. And this is similar to that last property, but here we have log of base A, log of base A. So if the bases of these logarithms are the same, then the arguments are the same. So look at this exponential equation. You cannot solve this by making the bases the same. You cannot solve this by writing it in log form. So we need another way to do this. So we're going to use that property we just learned. We're going to take the log of both sides. So the reason why I'm taking the log of both sides is it allows me to use the power rule. So once I have the expression written like this, I can take those exponents and write them in front. So I have x minus 3, which is multiplying the log of 2, and 5 minus x, which is multiplying the log of 3. And so what I'm going to do is distribute those logarithms. So when I distribute them, I get x times the log of 2 minus 3 times the log of 2 is equal to 5 times the log of 3 minus x times the log of 3. Now what we want to do is combine like terms. So every x term we'll put on the left, and the terms that don't have x's we'll put on the right. And then I'm going to factor in the next step. So I'm going to factor out that x on the left. Remember, I'm solving for x. So to get x by itself, I'll divide. This is our exact answer. The approximate answer is 4.226. So remember, if it asks for an exact answer in your homework, you're going to type this. If it asks for an approximate, you're going to type this. Okay, one more exponential equation. Solve the exponential equation 100 times e to the 0.08x is equal to 25,000. We want to solve for x. So first thing I'm going to do is divide by 100. And then the next thing I'm going to do is take the natural log of both sides. Why the natural log? Well, I'm taking the natural log because I want to get x by itself. And I can use that log base property, right? Remember, the log base e of e to this power is going to be equal to 0.08x. And that's all equal to the natural log of 25. To get x by itself, I'm going to divide by 0.08. Exact answer is here, and the approximate answer is 40.236. Okay, another property, which is going to help us solve our logarithm problems. So remember, when we were talking about logarithms, remember 2 to the x can never be equal to a negative number. It's for that reason that the log base 2 of negative 4 is undefined, because there's no exponent you can raise 2 to get negative 4. So remember, the argument in a logarithm, the argument is this parenthesis part, must always be positive. Okay, keeping that in mind, that's going to help us going forward with this next section. We're going to be solving log equations. Now, we have log base 5 of x equals negative 2. X is the argument which we are looking for, right? And we know from our experience with logarithms that we can rewrite this in exponential form. So 5 to the negative 2 is equal to x. And 5 to the negative 2 is 1 over 25. And that's the answer. Okay, another example. Solving this equation, the log of x plus the log of x plus 3 is equal to 1. The first thing we're going to do is the product rule to combine the logarithms on the left. Then what we're going to do is convert this to an exponential equation. Now the base is not shown, but we know this is a common logarithm, so the base is 10. So it's 10 to the first power is equal to x times x plus 3. Now I'm just going to go through simplifying that. I distributed x and subtracted 10. I'm going to factor that expression, and the answers are x could be 10 or x could be negative 5. But remember, the argument can't be equal to negative. So I can't have a negative number here, and I can't have a negative number here. So that means I'm going to have to reject that answer of negative 5. So the only answer to this question is 2. Okay, one more example. In this expression, we have logarithms everywhere. That did not happen before, but it's happening here. We're going to use the quotient rule. Quotient rule because we have a negative sign, or a subtraction sign, I should say. So on the left side, we have the log base 3 of x plus 14 over x plus 6 is equal to the log base 3 of x. Because I have log base 3 of something, log base 3 of something, these log base 3's can cancel. Those arguments have to be equal to each other. And then I'm simply going to solve this equation. I can use cross multiplication or multiply both sides by x plus 6. And then I'll set it equal to 0. Factor, and I get answers of 2 and -7. But wait, do any of these answers make an argument negative or 0? Well, I'll get a negative number here. I'll get a negative number here if I use -7. So I can't use -7. I hope that helps. I know that's a lot of information, but if you have to, you can go back, pause the screencast, and look at these final pages of all the examples that I solved here. These are the kinds of questions you're going to see in your homework. I hope it helps. Email me with your questions.